So webcams are technically required for interviews, but if that is an issue for you, the TAs will be lenient on that. But if I suspect any foul play, anything suspicious, then I will enforce the webcams for interviews. What is this week's interview for? For the lab. So, so you do have lab this week. It's a fairly simple lab. It's mostly setting up IntelliJ, getting that ready, cloning the examples repo, and just getting everything set up, your environment set up, so that we won't have any issues later in the class. So you have an interview just to show that off. This will be the quickest interview of the semester. It should only be a few minutes, and then maybe if you have questions for your TA, they should have a little bit of time, depending on how they're scheduling their interviews. Do we hand in lecture questions at all? Yeah, you hand in lecture questions in Autolab right here. You submit the code, and in Autolab will tell you how you did. So that's the lab. The first round of homeworks are also out. All interviews are not all on Thursday. Yeah, your TA should have sent you an email by now. Each time you have an interview early in the week, a TA will contact you with how to schedule an interview. So I'll answer more questions like that after lecture. I want to get into content here. So the first two homework assignments are out. Remember, you have to do one of the two for your application objective. So to complete the application objective for program execution homework, complete one of these homework assignments. If you want to do one of your extra assignments right now, Physics Engine does have an optional expansion objective, or as you know, you can do both. If you do both these assignments and the expansion on Physics Engine, you can get both of your expansion application objectives done right away. But with that being said, Physics Engine, I'm not going to go into these and really talk about them. But Physics Engine is doing a little bit of physics to build the physics engine for a game. The handout code for this assignment does contain the skeleton for a game, all of the game logic, and then once you complete your physics engine, you should be able to play the game that's provided in that code. Rhyming dictionary, given a dictionary of words and their pronunciations, how do you tell if two words rhyme or not? And I have a specific definition of a rhyme. There are tons of different definitions of what does it mean for two words to rhyme. So make sure you're paying attention to that very specific definition that I give in the assignment. It's if the last syllable sounds the same, which means all of its sounds are exactly the same after the last vowel sound, and the vowel sound is the same but can have different stress on it. So, and all the details are in there. But in a combination of this document and also reading the source documentation for the rhyming dictionary itself, which comes out of CMU. So with that, I don't want to spend too much time talking about those. Let's talk about unit testing. And also the graders on Autolab are not up for these yet. It's just the documents right now and the starter code. So you can do everything. You can complete the whole assignment. But probably tomorrow I'll have the graders live on Autolab so you can submit and have Autolab let you know how you did. But with that, let's go into some unit testing, go through some slides, and a demo today. So for the interviews, you'll get the email from your TA. They're not all on Thursday, but look at your TA's availability. They'll send you a Calendly link where you can sign up for an interview slot. Yes, do the lab before the interview this week. You should always come to an interview ready to present whatever you were supposed to have done, whether it's understanding a learning objective or completing a homework assignment for the homework interviews. You should always show up ready for it. You're not showing up there and doing the assignment in front of them. That's not how this works. I set up a time for an interview. I mean, these kind of issues aren't, that's inappropriate for Twitch chat. Contact your TA. I'm not going to, how am I even supposed to address that during lecture? Homework doesn't come up for me. Oh, never mind, you literally, yeah, I just added it. When is the homework due? I'm not answering that. Any question I've already answered like 18 times, I'm going to stop answering. When's the homework due? I'm not answering. Why did AutoLab give me a 0 out of 1? I mean, how can I possibly answer that, too? You guys, I mean, I assume you all get better throughout the semester, but how am I supposed to answer that during a live lecture? I would have to look at your code and everything. That's a Piazza or office hours question. Yeah, it's due at the end of the week. Time estimate for homework is literally the first thing on the assignment. That's my estimate of how long it's going to take you to complete. And some of you, I think, are just trolling. All right, let's get into lecture. So today's lecture question is going to be taking the code from last Wednesday's lecture question and testing it with a unit test. So here's the lecture question, and you do have to complete that lecture question to be able to complete this. So if you didn't do last Wednesday's lecture question, if you didn't get credit for that one yet, go back, finish that code. It's just implementing this formula for shipping costs. It's one conditional, one method. You should certainly be able to complete that by now. You should have been able to complete it last Wednesday. But anyway, if you didn't catch up on that, and occasionally there will be lecture questions that build on each other, so just be aware of that throughout the semester. And we want to write a test suite for this that's going to test this functionality. So if somebody has a compute shipping cost method, your test should be able to tell whether that method is correct or not. That's what we want to write, and we want to do that in an automated way where you can just run your testing code and have that figure out if the method is correct or not. So, what is testing? The Discord is the same each semester, but yeah, that's where you should go if you have off-topic stuff during lecture. You can always head over there. So, dude, why are you... I think one person asked if the homework is due at the end of the week, and now y'all are panicking. It's on the website. It's right here. Just read the website. If you can't even find that, you're in trouble. Like, I don't know what else to say. So how do we know when our code is correct? We want to write methods and know whether our methods are correct. The code we write, are these programs correct? It doesn't say February. Are you... Damn it. That does. No. I made this mistake before. I didn't update all the dates. But it's the Sunday after this lecture. So the Sunday after, the 27th? September 27th. It's in the right spot. I just have the wrong... In the right day. I just have the wrong month. I'll update that. But that's in the right spot. And again, that's it's kind of a hard deadline, kind of soft. It's however you want to look at it. But as long as you have an honest effort to complete the assignment submitted before that deadline, you'll get an extension. This class seems super disorganized. Yeah, right. Whatever. It's all organized. What's disorganized about this? You really aren't trolling? It's I mean, it says February instead of September. I don't think that's that big of a deal. Having been a student and taking lots of classes, I'd argue that this is one of the most organized classes you'll take. Yeah, thank you for that. I have February instead of September. If that's all it takes for you to say an entire course is disorganized, come on, man. And also the dates I don't have it in Autolab yet. Can't say that yet. But the dates will be in Autolab as well. So how do you know if your code is correct? There's kind of a progression to your testing. When you first start out programming, you might do something like submit to Autolab when that exists, which won't exist when you graduate. I will remind you of that throughout the semester. Autolab won't exist outside of academia, and even in some courses, Autolab's not going to exist for you. So you're not going to have that feedback. So if you don't have that, how are you going to tell if your code is correct? You actually have to be confident in your own code in some meaningful way. What does that mean, and how do we do that? So let's walk through an example of this code that we wrote last week for a lecture example, where we wrote this method that kind of computes if a number was large, medium, or small. A very simple, kind of meaningless program with no context, but if it's above this large cutoff or equal to it, it's going to be large. If it's below that but above medium, it's going to be medium. If it's below the medium, it's going to be small. So this was a simple method that we wrote, and we feel like it's correct. We feel like it has that functionality that we need, but how do we know? So we wrote a main method, and this is what we did in lecture when we saw this question. We wrote a main method, gave it a few inputs, ran the program, printed those values to the screen, and manually verified if the outputs were correct. So if this says large, medium, small, all on separate lines, I'm feeling good about my code, or at least that's how that's what we did for that lecture to make sure that this code was working correctly. There's a big problem with this. It's okay for these really small, like for this program, it's whatever. But what happens when we have hundreds of files with thousands of methods? We have this huge code base that we're running, and to test this entire code base to make sure everything's correct, we're printing tens of thousands of pieces of output to the screen, and then manually verifying every single piece, every single input for every single method, all the interactions between them. If we're just running a main and printing to the screen, this is going to get way out of hand really fast. We're not going to be able to do it. It's completely infeasible. So what we need is some way to automate this process for when the code bases do get larger, when we are working on much bigger code. Yeah, don't do RMRF in your terminal. That's obviously a troll. So how do we automate this? So if we want to run a lot of tests. So before in that main method, we saw a series of 3 tests. That should say series, not serious. 3 tests in our main method. We want to run a series of tests like that, but in an automated way and with conditions that check whether that is correct or not, so that our code can automate the process of checking our code. That wasn't a ban, that was a timeout. So if the code's correct, all the tests need to pass. All of your tests in that code need to pass. If even one of those fails, if even one of the outputs was not what we expected, then that code fails. That code is not correct. Since there existed an input-output pair for which it didn't produce the right output on that input, the code is wrong. It's just wrong. You can't have certain cases where it's going to fail. So you need to address every possible thing that can happen in your code, everything that could go wrong, add tests for every single one of them, and then make sure that your code passes on all of them to make sure you don't have any errors. So let's revisit this code. I don't have the method in place right here on screen, but we are going to call that compute size method in a test suite. So this is the structure that we're going to see for unit tests. I'm going to write a whole separate file and put it in. I'll typically put these in packages named tests, and for homeworks and lecture questions, I'll stick with that. And this is going to be the structure of how we're going to test. So this is the same testing that we saw in that main method, except organized as a unit test. So let's talk about what this is and what we're doing here. So for one, we're using a library called Scala Test. So we do have to download that library somehow. We're going to use Maven through a pom.xml file. This is similar to requirements.txt that you used in Python. And it's similar to I don't think you used it last semester, but package.json in JavaScript. I don't think we actually used that. You just imported from the browser. And then we're going to use Maven to run that, look at that pom.xml, and download this dependency. I'll give a demo on this after I'm done with these slides, so you see exactly what I mean. For now, just know that Scala test is not a part of Scala, that we do have to download it separately, and if you get all kinds of errors right here, if it says, I don't know, if IntelliJ says, I don't know what Scala test is, that means you gotta fix your Maven, get your pom.xml going, and get that set up. So once you do have Scala test downloaded, installed, and linked, then we can write code like this. So let's go through this and talk about what each line is doing. So first, the import. We need to import this. It's not nothing is automatically imported except a few modules like math and printline, the system methods. Scala test we do have to import, and I'm using this underscore character. This is Scala's wildcard. It means import everything from the org.scalatest package. So in Scala test, there's a package named org, a subpackage named Scala test, and then in that subpackage, there are a lot of classes and methods that we want to use, and we can import every single one of them just using that underscore. Next, we're going to use one of the classes that we just imported, this fun suite, short for function suite. And we're going to extend that class. We can ignore for now what this word extends means. Just know that you can name a class whatever you want. In the homeworks and lecture questions, I'm going to specify what the test suite needs to be named. So if I say name your test suite test all rhymes is one of them for rhyming dictionary, you need to name this test all rhymes, and that would also be the file name for your test file, testallrhymes.scala. It extends fun suite, meaning it's going to get a lot of functionality from this library. The extends keyword, we'll talk about that when we get to OOP in 2 weeks. We'll start talking about what extends actually means. For now, let's focus on one thing at a time and ignore it. Since we get a lot of functionality from fun suite, we can start using it. One of the pieces of functionality is this test method. We're going to call the test method, which is going to give us this testing functionality. We're going to name this particular test, whatever I want to name it. Here I'm just going to give it some descriptive name. Doubles are checked for size in each category. So I'm going to test these doubles for the size, something descriptive, something where you're going to know what that test means. This name is going to display when you run your tests, so having it something meaningful, especially if you have a lot of tests, is going to help you out. And then finally, the code that we want to run. There's no main methods in a test suite, but every test, and you can have multiple tests if you want to have multiple tests in the same test suite and give them each different names. You absolutely can do that, and that's encouraged, especially in certain cases. I could break this into 3 test suites, one for large, one for medium, and one for small inputs. I didn't here, but that we certainly can, depending on how you want your test code organized. But this code in this block of the test is going to be executed when this file is ran as a test suite. So there's no main method. There is actually a main method defined in fun suite. It's buried under a bunch of other functionality. We don't have to worry about it. We just have to worry about the tests that we write. So this, I can show an example of it being split in 3 when I go to the code. I'll be going to IntelliJ after these slides. There's not too many slides today because I want to do a longer demo. Yeah, there are instructions on installing Scala test. That's part of my IntelliJ demo today as well. I'll go to the IntelliJ and show you exactly how to do these things, but I want to get the concept of unit testing down first. And whenever we need to check something, we're going to use this assert method. So assert, we're going to call it with one parameter and an optional second parameter. The first parameter is always a Boolean expression that needs to be true. If this Boolean expression is true, if it resolves to true, then we'll say that assert passed. So that part of our test case passed, and our code is looking good. So if all of our asserts have a true as their Boolean expression, if all of these are true, the large double, when I call my method compute size on the large double, which is 70, I expect that to return large. On the medium double, I expect that to return medium. On the small double, I expect that to return small. Tiny side note for Java, if you're coming from Java, we can use equal equal in Scala. That doesn't break things. Using equal equal in Java does break things on occasion. Equal equal in Scala is fine. Equal equal actually calls the dot equals method, which handles the issues that can be caused. So if you're panicking, if you're from Java, you have Java knowledge, and you're panicking seeing these equal equal, this is legit in Scala. The second optional parameter is a string that's going to be printed out if the test fails. So if this test fails, I want to know on which input it failed. So I'm going to print 70 to the screen. It's going to say, your test failed, what the hell? And here's your, we call it hint text. Here's your hint, the 70.0. This is what you told me to tell you if this test ever fails. For this, I mean, the example is simple enough that we don't really need the hint text, but it's going to help once the tests get larger and more complicated. And I'll show that too. I am looking pog. Is assert a class name or a method name? Assert is a method name in the fun suite class. So we call this, it has a lowercase. Since it starts with lowercase, you know it's a method name. If it were uppercase, it would be a class name. But this is a method in the fun suite class that we inherited that we're now able to call. Dot equals still works too. Yeah, you can use dot equals if you want to. But the equal equal method does call the dot equals method in Scala. And equal equal is actually a method. There's a lot of fun stuff that goes on behind the scenes of Scala. It's a really neat language, but equal equal is a method that just defers to the dot equals method. So, the start of this conversation, this is a big question. FunSuite is part of Scala Test, so once you install Scala Test, it'll be there. You'll be available for you. So, how much testing is enough testing, and what should you test? So, for this example, is this enough testing to grab one input that's large, one that's medium, and one that's small, throw these at the code, and saying, well, that passed, so my code is good. Are we confident that our code is actually correct with just these three inputs? Yeah, you can call assert once you extend FunSuite. This class will return an A for all of us. It'll return an A for all of you who put in the work. Nope, this is not enough testing. I'm seeing some no's come in. Nope. Negative. Actually, I don't. Yeah, I think I did do some negative. No, we'll see in a second. But yeah, we should have negative numbers and all kinds of crazy numbers in there. So this is the correct solution for this problem, assuming that we want the boundaries to be 60 and 30. I'm going to do if this was a lecture question, the lecture question would be like, the boundaries are 60 and 30. If it equals 60, it should be large. If it equals 30, it should be medium. Everything else is defined by these cutoffs. So this is the correct solution for this, or a correct solution, I should say, for this problem. This works. It always returns the right output. We can tell because it's just such a small question that we can manually verify that this code is correct. That won't be the case for most problems that you do in this class once things start getting a bit tougher. But here, with boundaries of 60 and 30 that we want, here is an incorrect solution. I have the boundaries incorrectly at 65 and 20, but this passes my unit test. The test that I wrote never checked that close to the boundaries, so this incorrect solution is going to get a pass from my unit test. That test suite is passing on this test. So this is a problem. So this certainly isn't enough testing, the test suite that we wrote. That's not enough testing because it passes this solution. So this test, 70, 50, 10, checking in those three inputs, this is going to pass. That's a problem. So we got to get closer to those boundaries and make sure that we are actually enforcing the boundaries of 60 and 30, not just taking one input from each category. So this is a bit more testing. We want to make sure that a 60 right on the boundary is going to be a large. We want to make sure that the endpoints of the medium boundary are going to be medium, and the largest small should also be considered small. So now we're getting right up against those boundaries, testing those boundaries, and that incorrect solution from the previous slide is now going to fail. This test suite is a bit more solid. It's going to say that code was incorrect, and it's going to be tough to write incorrect code that passes this test. It's certainly possible, but it's a bit tougher. So now that we're testing those boundaries, is this enough testing? If you wrote this for your lecture question today, if you just tested the boundaries of the shipping cost computation, is this going to be enough testing? This is a tougher question to answer. You can certainly argue that this is enough testing. You can certainly argue that it's not enough testing, but this at least is getting to the range of being acceptable for testing. A lot of you throughout the semester, you'll come to me in office hours and the TAs having testing that looks like this. We want to avoid that. You need to really test if your code is correct. But if you have tests that look like this, we're getting better. But is it enough? And at this point, I think it's more a question for each developer. What are you comfortable with to make sure that your code is correct? Is this enough testing? Maybe, but we can always go further. So something, and especially once we have a lot of tests. So this is more thorough testing. We're really getting the boundaries. We're getting very large numbers in here as input. We're hitting it with negatives and the 0 that were mentioned in chat. We're getting still getting the boundaries. We could even go a few more 9s out here to make sure we're really hitting the boundaries. But this is going to be, very few people are going to say that this is not enough testing. Though you could always argue for more testing. There's always an argument for more testing. But here, I want to show off some data structures. We didn't have data structures examples on Friday. I just kind of threw data structures at you. So let's talk about how to use these lists as well and get used to using data structures in Scala. So here I'm going to create 3 lists of doubles. The first list, these are all the inputs that should return large. Second, all the inputs that should return medium, and then all the inputs that should return small that I'm testing at least. I'm going to use the list keyword, and then in parentheses give it the initial values for that I want in that list, and actually technically the values that will be in that list for its entire life for that list. Assign them to a list of some type. Data structures in Scala, since Scala is strongly typed, data structures in Scala can only store one type of variable. So here I can't just say give me a list. This variable is of type list, and this is just a list. We have to create a list of a specific type. So this is specifically a list of doubles, and we denote that using these brackets. A list of double is how this is read. So I'm creating a variable named large doubles of type list of double and assigning it to a new list with a list of values that are stored in that list. And notably, we haven't really seen this yet, but we'll see it soon. We don't use the keyword new when creating a list or an array or a dictionary or several other Scala types. We're not using the keyword new to create a new list. We will use that later on when we create our own classes starting Friday, I believe. But list, create the list, give it all the initial values. This is all the syntax. You're used to data structures, but this is the new syntax that we're seeing. Same with mediums and smalls. So, and if we want to modify a list, this is just a flashback from last time. It came and went very quick in Friday's lecture, so I want to make sure I emphasize this. If we want to modify a list, we can use this method :+ to append a value to the end of a list if we want to add a new value to the end of it. So I decided later I want to test 10,000 as well. I'm going to add that to my list. Going to append it here. But what this does is, or what this doesn't do, it doesn't modify the list that we created here. So this large doubles is referring to this list here. This list actually never changes. It will always have only these values in it. So when we call the append method and append a new value to the end of the list, this list is actually not modified at all, but this does return a new list with all of these values in it and this new value appended to the end. So what this means is that the variable large doubles, which is storing this list, we want to reassign that to the new list that we just created. So we have to assign large doubles equals the new list with all of the values of the old list that we were using and the value 10,000 appended to the end of that list. So this is kind of a beginner's trap. This is a little tricky to get used to. You don't just say like list.append and then the value that you want to append to it, because lists are what we call immutable in Scala. We can't change a list once it's created, so we have to create a whole new list with the modifications that we want added to it. This is very similar to strings in most languages. You have to reassign the value strings, ints, doubles, all these values, all these types, you have to reassign the value. You don't say x plus 7, you say x equals x plus 7 or x plus equals 7 to modify the value actually stored in that variable. Lists are the same way in Scala. We have to reassign. If you forget to reassign, we'll see it in office hours a lot. Especially once the first assignment comes where you have to modify a data structure. We'll see it a lot in office hours. A lot of you will forget this, but I want to emphasize it as much as I can to limit the number of you who will have issues with that. I put var instead of val because I need to make this reassignment. This reassignment would crash if I used val here. If I used val for the larges. So the other two I use val because those lists aren't changing. The value stored in these variables is not changing, but the value stored in this variable is updating to a new list, so I have to have this one defined as var. And then finally, using iteration, I'm going to iterate over all of the large doubles, call compute size, make sure it returned large, and if it didn't, this is where the hint text comes in a lot handy. If it didn't return large, I want to know which of these inputs failed. Because otherwise the test suite's going to fail. It's just going to say, it'll tell us the line number, but it'll say this line failed, this assert failed. One of your larges didn't return large. Your method didn't return large on one of the large inputs like it was supposed to. In this case, I do really need it to print out which one. Was it the 70? Was it the 60.01? I want to know which one it was so it can help my debugging. When I go back to my code, back to my method, and start fixing things, what specifically should I fix and where should I start looking? And then same with the mediums and smalls. I'm going to check for each one, does compute size return medium? Does compute size return small? If it doesn't, let me know which one is wrong so I know where to start my debugging. Any questions? I'll read some chat here, but any questions on this example? This is really the first big unit tests and data structures, iteration, a lot of new stuff going on here. So let's digest for a minute before we go on to the next thing. Which large double is the method? I'm not sure I understand the question. But I'm iterating over large doubles, which is all these values plus this 10,000, storing those in variables of large double, and then I'm calling conditional.computeSize, the method that we're testing, on each one of these inputs and making sure that this method call returns large on each of those inputs. And if it doesn't, print out which specific double failed on this test. If you were adding 10,000 without the decimal, would it crash? No, Scala is good about auto conversion when it can. It would convert the int to a double. Why not make everything var? Is it more efficient to do val? It is a little more efficient to do val because the compiler can do more optimizations behind the scenes. But really, the reason I like val personally is it lets myself and any other developers looking at this code or working with this code know that I don't expect the value stored at this variable to ever change. So it can help with that. It also enforces, the compiler will actually enforce that the value never changes. So if I don't expect this to change, I'll put val here. Then if it does change at some point throughout my code as I keep coding, the compiler is going to say, yo, you told me this wasn't going to change, and then you changed it. What's up? What do you want me to do here? And it's going to halt everything so I can fix that problem. If you declare var all the time, even if you don't expect it to change, you don't get those protections. You don't get the compiler looking out for you in that case. And then if you accidentally do change it when it's not expected to change, you can run into some issues. It just makes debugging easier if you let the compiler work with you instead of against you. If you use var for everything in this course, until we get to functional programming, that is, I ain't gonna care. You'll never get points off or anything for that, as if there were points. Why do we put small double again in the cert line? That's if the test fails, it's going to print that to the screen for me. At the bottom of today's slides, what are those functions there for? I mean, we'll get there. We'll get there. Those are the tests, the incorrect solutions in my test suites, in my testing on Autolab, though, is the short answer. You don't have to retype your question. It's still on the screen. And it's just too much to process quickly, though. Would want to know which number isn't considered a large. Is there like a code line that we have specifically right for it to have a minimum value? Like if it's less than 49, it's no longer considered large. So that's just defined in the problem statement. If the lecture question is the cutoff should be 60 and 30, I didn't explicitly show like what the problem statement would be, but we're just assuming that the cutoffs are supposed to be 60 and 30. So the lecture question, if I said the cutoffs are 60 and 30, write a method that returns large if it's greater than equal to 60, etc. It's arbitrary. It's just a question that I made up for the lecture example, but we're assuming the cutoffs are supposed to be 60 and 30. Yes, there are always better ways to test. I'll have to give an example of a dictionary, especially for Wednesday's lecture question that'll come into play. But let's keep moving here. So, are these posted to YouTube or only here? So each homework and many of the lecture questions are going to have testing objectives. If you look at the homework assignments that I released today, there are three, I think I just call them objectives these days, but I see them as testing objectives, where you're asked to write a piece of functionality and also write unit testing for that functionality. So I'll say, write a method that determines if two words are rhyme with each other, and also write a test suite named test is rhyme that tests the functionality of that method that you wrote. This is going to happen throughout the course, so get used to these kind of objectives. Today's lecture question is the first one that you're going to see, that you're going to do, that will follow this this structure. And whenever I ask you to write a test suite for an objective or a lecture question, this is what I'm going to do on Autolab. I'm going to take your test suite, I'm going to run it against your solution, and it should pass on your solution, of course. If it doesn't, why are you submitting it? Because you can test that in IntelliJ. You don't need Autolab to help you out there. Run your test suite against your own code. Sometimes this will fail just if we have different naming conventions or something. There are strange things that can happen for this to fail when it passes on your machine. We'll work those out throughout the semester. In office hours, we'll help you out, find what you did wrong on those. Usually not following the naming conventions of the assignment. Anyway, it should pass on your solution. I'm also going to run it against my correct solution. I'll have a solution That should say on, not O. I'll have a solution on Autolab. I'm going to run your test suite against my solution. It should also pass on that. This, there usually can be, let me rephrase that. It's not uncommon for there to be discrepancies between these two. If you coded your solution wrong, but then wrote test cases that are also wrong to test your code, but that don't follow the description of the assignment, that happens a lot where you'll pass on your solution but fail on a correct solution. That means your code and your testing is wrong. So make sure you look at that. So I'm going to test it on my correct solution, and then I'm going to have a variety of incorrect solutions on the server, and your test suite should fail all of those incorrect solutions. Your test suite should be able to distinguish between correct solutions and incorrect solutions properly. If it can't determine between all of these, pass on these, and fail on all these, then you haven't completed that objective yet. So if it passes on these two, but also passes an incorrect solution, you have to add more testing. You haven't done enough testing at that point. You got to write more test cases and make sure you're more thorough in your design of your test suite. Another warning, I didn't add this to the slide, but it's in the homework descriptions. You can pass on yours, pass the correct solution, and fail all the incorrect solutions without having correct code. That is possible. It does happen. The incorrect solutions are not meant to be comprehensive. I don't have an incorrect solution for every possible mistake that could ever be made. So you can complete a testing objective with incorrect code, and then that catches up to you later on in the assignment when you're working on what I call the primary objective that uses your testing objective code to complete it. If you're really struggling trying to get the primary objective complete, go revisit your testing objectives and make sure you did thoroughly test, not just barely test enough to get my incorrect solutions failed. But this will make more sense once you do today's lecture question, once you get your feet wet and how the testing objectives are assessed in Autolab. All right, so with that, Autolab question mark. So every lecture question and homework, you'll submit it to Autolab, which is an auto-grading thing. So if you scroll to the top of the course website, the blue circle with the check mark, that's your link for Autolab. That's where you're submitting all your code. So Maven, there's nothing stopping you from starting the homeworks. But we didn't talk about objects and classes, which will be Friday. So that'll make it a little tough, but you can still start, at the very least, start thinking about, reasoning about what's given, and start working with, start brainstorming your solutions. At the very least, I think you could just kind of guess what objects and classes are in the context of the homework and work on it that way. We haven't even introduced stack and heap yet, but yeah, I do want to emphasize stack and heap more than I did in previous semesters. So Maven we're going to use to import Scala tests. It's going to depend on a pom.xml file. This is something that I'm going to go to the demo to show, going through the slides isn't. And because I don't want to come back to the slides, I'm going to show this this last part. The lecture question again, of course, test the lecture question from last Wednesday in a test suite named unit testing in a package called tests. But also this last slide that was mentioned in chat, I want to, if I have extra slides like this, I won't always show them in class, but since this doesn't really make sense to you right now, I want to explain this one. But I usually won't show the bonus slides if there are, they're usually hints for the lecture questions. But for the incorrect solutions on Autolab for this lecture question, there are 5 incorrect solutions that I'm going to run your tests against, and these are those incorrect solutions. So I'll have incorrect solutions for every testing objective. I will almost never actually show the incorrect solutions like this, but just so you understand what is happening in Autolab, in the test code, because it's going to give you these names, rounding weight, and it's going to tell you whether it passed or failed, always over 30. You'll see these when you submit your lecture question for today. This is the actual code for each one of those. So you can look at this code, look at your test suite, and know exactly what happened there. Or you can even paste this code into Autolab, or not in Autolab, into IntelliJ, and run your test suite against it and verify that you actually do pass these incorrect solutions. So, for example, always under 30, it doesn't have any math. If you only tested things below 5 pounds, you're going to pass this. If you only test things over 30 pounds, this is going to pass. You need comprehensive testing so you can check everything. One with the boundary just a little bit off, etc. So that should help you see what's going on with Autolab. After this lecture question, there'll just be the names of the incorrect solutions, which are meant to be kind of obscure hints as to what might be going wrong in the solution that's provided. Yeah, and can I get, there we go. My goodness. Did I not? Oh, because we're in week 2, obviously. So here it was called for in chat. Here's an example of having multiple tests in a single test suite. These are just the progression of the tests that I showed in the lecture. So the first one, I have this as one test, testing all this. Another completely separate test, I'm going to call test again, give it a new definition, call test again with a new definition, and each time I have to give it a different name. If the names are identical, it'll give you an error. And with tests, I have all these green arrows I can hit, or go over to the test, right-click, and run it just like you're running a program with a main method. And once I run this, I'm going to get some feedback about my code. And here, everything passed, so there's not much to say, but I got this green check mark. That means everything passed. Your code looks good according to these tests. And if I go to conditional, week1.basics.conditional.compute size, which is this method that we wrote last week, if I break this, and since that test suite was the last thing I ran, I get to use this button now. I see that my first test is passed, but the next two, size boundaries, are checked, and use many tests for each category. These both failed, but the first one doesn't show up. That one did pass. So I got 1 pass, 2 failed. And it's going to show me the line that failed. With this, I can tell exactly all the information I need from looking at the code. But I also have this second argument, large double, which is going to print what the input was when it was called. So, and the test suite is good about giving you extra information as well, but usually you want that value as well. So when we go to the next one, it was 60 that failed, because I can tell right here, 60 failed. And then it's not going to run the other ones. It's just going to tell me the first one that failed for what it's worth. But that is going to tell me what failed. And then after that, once one assert fails, it doesn't run the rest of the test. So it never even ran medium and small because I was already wrong. And oh, shit, just 1 minute. I thought we had more time than that. So, quick Maven tutorial. What I recommend, just so we don't have to worry about it because it's not, a core part of the course. I have this pom.xml in the examples repo. I'd recommend just taking this POM file and pasting it into any project that you have. Once you paste this into your project, and it has to be at the root directory. So this is right in the root directory of the project. Get it right in there, and then once you do, there should be this Maven. So let me break it first. So I just deleted a dependency. I have something broken. Actually, I don't want to track down what I broke. What uses this. But once I get this POM file in the project, I can go to the Maven tag, hit refresh if nothing shows up. And then this will download all the dependencies. Actually, I know what I'll do. I'll delete everything. Import changes. Week 2 testing. And what I'm going to get is an error right here, and then everything that used that package is going to be an error. So I don't have Scala test installed right now because I removed it from my POM and updated all the dependencies. So I don't have this library anymore. So this is the error you're going to get if your Maven is messed up. To fix that, we're going to go to the POM, fix whatever's wrong with the POM. Fix whatever's wrong with the POM. There we go. And since I already have this link to my project, I get this dialog box and I can just click import changes. But if we don't have that, which you won't if it's your first time doing it, and in fact you won't have this either, sometimes when IntelliJ is first installed, you won't have the Maven tag either. So if this is your situation, you have the POM, but nothing's, you don't have the buttons. This is what I want to show because this is what we get often in office hours. Click this magnifying glass. Search for Maven. And that will put it on the sidebar for you. Once that's there, this sometimes won't show up. Click the refresh. And I have all my dependencies installed. So that went through, and if that doesn't work, sometimes go to download sources and documentation. Sometimes that'll give it a little kick too, to make sure that it downloads everything. So what this does is in these dependencies, inside these dependency tags, which uses XML, somewhat similar to HTML formatting, we're going to list all our dependencies that we need for this project. And if you use this POM from the examples repo, it's going to have everything you need for the whole course, which this week's lab is making sure that you have all of this set up properly with the right versions of Scala, the right version of the JDK. Here's the Scala test one right here. This is saying, hey, download Scala test for Scala 2.12, version 3.0.5. And it's going to download that package. Once that's downloaded, it's going to link it to all of your code marked as in the source directory, and you're able to import that wherever you need it. All right, so that's... That's that. And so that's the end of lecture content today, and we'll shift into just chatting. All right. So sometimes the content goes quick. And I'll show extra examples during this portion, but I won't introduce new content or new material. Is there an easy way to update Scala? I have 2.12. This is something that affects a lot of people, especially if you have 2.13. And this is something I really can't fit in lectures. Lectures are just so packed. But if you go to, oh man, I haven't even done this in a while, project structure, and you'll see your Scala SDK. Let me actually remove this and break my project to show you how to fix this one. But I don't have any Scala right now. And I'll actually get this on top. Hey, you don't have any Scala SDK? What's going on? And I can click that and help me set it up. Or I can go to the project structure. I'm going to add a Scala SDK. And it's going to give me this list of possible versions that I have. Or I can download a new one. If this list is empty, or if it only shows 2.13 or 2.12.0, as the question was in chat, go to download, and it's going to give you a list of all the Scala versions that you can download. Go to 2.12, and whatever the latest is, it's 2.12.12 right now. And that's going to download your latest version of Scala. And it's going to link it to my project for me, and now I have 2.12.12 right here. So I just updated my Scala. I think it was 2.12.9 I had a few seconds ago. Now I have 2.12.12. Similar with the JDK, you need 1.8, but that's a bit trickier to set up because you do have to go to Oracle. You have to create an account, download 1.8. The Oracle just makes you go through a few more steps. But once you download that, find where Java installed to. It should be close to wherever the default one is. If it doesn't show up, find that JDK on your machine wherever it installed, and then get that linked up to your project. So updating Scala is actually pretty easy. Updating the JDK gets a little tougher. I see a bunch of arrows. What's the question you're pointing to? What should we do if Maven doesn't even show when you search for it? Oh my. That happens? Is Maven a plugin? Yeah, it's a plugin, but it comes with IntelliJ. I have an update to this plugin too. Scala is a plugin that you do have to download. If you create a new project and you don't see an option for Scala project, you may have to download this. I thought it does come with IntelliJ these days, but it didn't say bundled, so I'm not restarting right now. But you may have to install Scala, but Maven should be there. I've never heard of Maven not showing up in the search, so that's interesting to say the least. That might have to be a office hours question or possibly a Piazza. That would be a tough one to answer on Piazza, though. How can we get access to that example in which repo? So that's when you go through this week's lab, it's going to show you how to clone this repo and get this repo set up on your IntelliJ so you can run all the lecture examples. So go through that lab. It is the repo linked at the top of the course website also. So if you already know how to clone repos and know what you're doing in that regard, this is the examples repo. This is the one that I have shown right here. I think a few of these directories I don't have, like the 312 stuff. Some of the things I kind of added, I guess most of it is in there. But just the 312 directory isn't pushed to GitHub. There's nothing that says Maven. I'm not sure about that one. Yeah, and there's Piazza posts on how to set up all your IntelliJ. This is one of the rough parts. It's one of the downsides of using a desktop IDE instead of online IDs like you did last semester. There is some setup. The setup is painful, but the TAs and myself were ready for it. With Maven not showing up when you search, I'd have to see, like, that would be an office hours question, so you can share your screen and we can walk you through our debugging process. There might just be another way that you have to access Maven. But I would check your plugin like I did. Make sure that you do have the Maven plugin installed. And then try searching it from there after that. Make sure you have IntelliJ Ultimate. Maybe you got the community version of IntelliJ. It's possible that that doesn't come pre-packaged with Maven. I'm just speculating here, but those are the things I would check. And I'll have to have office hours this week. Mine are probably going to be Thursday evenings are going to be my office hours. And I don't know if I'll have a second time throughout the week, but if I do, I'll let you all know. If the POM file exists in the root folder, do I just need to run Maven package and install? I wouldn't run like the Maven commands themselves. I would use this interface, but if you are familiar with Maven, feel free to go to the command line and run those commands. Usually if you do some command line, IntelliJ might not pick up on that. IntelliJ might not link properly. So I would prefer using this. But if you go to Maven on the sidebar, this is calling package and install and other Maven commands for you. But if you do it through the interface, so you can run all the commands right from here. But if you do it through the interface, you know IntelliJ is going to know what's up and what you did, or else it might not link. Yeah, so when I did week 1... So when I did import week 1 basics conditional, it looked in the week 1.basics package for an object or file, a Scala file named conditional, and it pulled this exact code right here, which is currently broken. And since it's in the same repo, it was able to find that. But if you're using a class or an object in a different package, so like if I had this code right in the week 1 basics package, it can already see all the other objects and objects and classes in its own directory, or in its own package, I should say. But since this is in a different package, we do have to import it and specify which package to look for this conditional object. The POM file goes in the root of your directory. So right in the root, if you're doing it manually, new file, pom.xml, and then paste the contents in there. It's not a new object. It was new. It's a new file. It's just a text file. An XML file, technically, which is just text. Can you show to download Maven again? To run the dependencies? It's this. So once you find it on the sidebar, if it's not on the sidebar, do a search for it. Once you do that, hit this refresh button. That's going to download all the dependencies for you. And I recommend downloading the sources and documentation. It gives you the ability to do this incredible thing. Hold Control click, and it's going to take you to the source code, which is sometimes unreadable like this one. But it's going to take you to the source code of all of the code in that library. Like for example, test read runner. Well, I'm not going to be able to find it quickly, but somewhere in there you'll actually find the main method. But it's layer after layer of imports. And this is, for those of you asking about the POM file, and this is just a directory on your machine. If you do show and I'm looking at for finding show and finder, but this is just a directory, and POM is just a file named pom.xml. If you get it in that directory one way or another, it'll be there. But if you want to create it and paste that showed up on I just realized you can't see that when that opened. But it's just a directory on your machine with the pom.xml file in it. If you get it in that directory one way or another, it's going to show up. You're going to have it in here. You may have to reload from disk. You may have to do that to make sure that IntelliJ sees it. But as long as you get it in there one way or another. Or you can do the method that I showed. New file, call it pom.xml, and then cut and paste the contents from my repo, from my pom.xml, into yours. That'll also work. And then, whoa. Settings to readjust the JDK. The JDK is a little trickier. I'm not going to go through the Oracle stuff and download it, but you download 1.8, JDK 1.8 for your operating system from Oracle and install it. And then when you go to project structure, SDKs, you have to add the JDK and select somewhere on your drive where that installed, which can be tricky to find where it installed to is the tough part, but that's different for each operating system. And select that directory where it installed to, and then it'll install all the JDK stuff. And creating any file, like if I just went to create file and I named something like thing.scala, it'll take that extension. Like these are all just text files. There's nothing magical. Except there's little things like adding the package declaration to that. Even if I just do file, there's nothing magical that happens when you do new object or anything. It just names the file extension .scala and gives you a little bit of structure to start with. But you don't have to do that. I can do new file and just name it whatever. So with the POM, I just did new file and just named it pom.xml, and then IntelliJ will treat that as a XML file. What is Maven goal? The fact that you're using MVN as a shortcut, like where'd you even get that from? You shouldn't be in the command line with Maven. We don't have to make it that complicated. You just add the pom.xml file and let IntelliJ do the rest. Have it find that Maven project and I only got 2 minutes till 4:42 here, but like if I create a brand new project, I'll name it Untitled because I'm going to be clever like that. And then and I don't have any Maven here. I'm going to search Maven. Maven settings, add Maven project. Maybe this is what you're talking about. Maybe this is what you've seen. This is an easy one to fix. So I'm going to go to my project. I'm going to create a new file, pom.xml. I'm going to my other repo, copy, paste. Click whatever says Maven on it. That got my sidebar. It linked everything, and now I have everything installed from Maven. So that's the whole process you go through. Create that pom.xml, search for Maven. That gives you the sidebar. If none shows up, click the refresh, and you'll have all those dependencies installed.